Hello, ICS2O folks. Um, Before we get into the lesson on conditional loops, whatever those might be, I'm going to say a few words about the warm-up today. The warm-up today, you were asked to write a program that gave the user 3 attempts to put in a password, whatever password you decided, and output some sort of message if their password was correct, or another message if their password was wrong. So um, no, not that one. This is probably what your program looks something like. Uh, Notice a couple things. Once I use this keyword const, which stands for constant, and then I use that for my password, so I didn't have to put um, the actual password that I wanted. So my password is hello in capitals, and so then I just changed. I had that down here. Okay, so CONST stands for a constant. We've seen it a couple times, like pi we used for a constant when we were calculating the area of a circle and so on. And you had a for loop because we knew that we wanted to give them 3 tries, so it was 3 tries, and it works okay. Oops. I should have a colon there like that. That's what it was telling me. Please enter your password. So if I say, oops, invalid password, you have 2 more attempts, and it's telling me how many more attempts I have. What's funny about this program, stupid, really, that if I put in the actual correct answer, it says, thank you, please proceed, and then ask me for the password again, which is silly. So if I put in yes, now it says it's invalid again, and you have 0 more attempts. It should have conked out somehow during the second one. As soon as they had their correct password, we should have been able to get out of the loop, and we can. And the command is exit. Exit, what exit does is get you out of that immediate loop. So if I run this now, please enter your password, and I type in hello, done. It only actually executes the for loop once. So that's a kind of a neat thing to do, is use the exit command. We'll see the exit at work today when we're doing conditional loops. So you have a word processor fired up. I don't think we need to draw any pictures, so you don't necessarily have to be using Smart Notebook. But you've got that fired up, and you've got Turing fired up from the warm-up. Hopefully you're taking that up. We're going to be typing in some code. We use the loop end loop structure when we aren't sure how many times a loop will execute. We first talked about, I'm going to get a new one going here. Loop end loop are loops when we talked about shampoo, the shampoo instructions, right? Lather, rinse, and repeat, right? That's the shampoo instructions. If I run this now, oh, geez, it's going so fast I can't even see what's going on. So I'm going to stop that and put a little delay in. You don't necessarily have to be following along with this, but it's kind of nice if you do. So lather, rinse, repeat. Lather, rinse, repeat. Lather, rinse, repeat. Lather, rinse, repeat. When will this ever end? It won't, because there's no way out of this loop, right? There's no way out of this loop. So this is what's called an infinite loop. It's a loop where there's no way out. The counted loops before ended after a certain number of times through. So this one, loop end loop, where these statements will be executed, this is an infinite loop. It will never terminate. We actually had to stop our program. And that's not very good code for that to happen. We want to avoid infinite loops. However, we can terminate execution of the loop with a condition placed somewhere in our loop. And here's what it looks like. Some sort of condition. There's actually a couple of ways to do this. So an exit when condition is, is one way, and I'll show you how that works, where I could have statements before or after the exit when command. So I'm going to show you that. That's my password program. I'm going to close that one down, actually. Nope. So here, I'm going to say loop, but exit when answer equals yes. And I'm going to ask in here, put stop, question mark, and a little prompt there. And of course, I actually need to declare this variable answer, and it's a string. So I'm going to ask the user when to stop. Get answer. And so then this loop will exit when the answer is equal to yes. If I run this right now, it's asking me to stop, and I'm going to say no. Lather, rinse, repeat. Stop. No. Lather, rinse, repeat. Stop. Yes. And then it stops. So that means it got out of this loop when I entered the answer yes. Now notice it might make sense for us to take this condition out and put it near the end of the loop, so we at least wash our hair once before we have a chance to repeat or not. But again, those are things that you'll work on as you work on your program, whatever makes sense to you. And so there is another way, though. I could, just like I saw in my warm-up question, I could put the exit command in an if statement. So if condition, then exit. Um, and if I wanted to, I could have multiple exit conditions in our loop. So if this, then exit, or exit when, I could have several of those statements somewhere in my loop, and that all works just fine. Condition here is that idea of some sort of condition that can be either true or false, and it could be, a condition that has an and or an or in it, could be about numbers or strings or whatever. And this is what's called a conditional loop. You can see why. It has a condition in it. Go figure. What a good name. All right, well, let's keep going. It says we can use a conditional loop to control user input. So, for instance, one example, control user input is we could, and I'm going to just change this a little bit. So if we're going to change this to our mark program again. We've been using the mark program again as an integer. And in here, I'm going to say put, please enter a mark. This is from 0 to 100. A little prompt. Keep it on the same line, and I'm going to say get mark. And I'll say exit when. Well, what do I want to do? I want to make sure the mark is between 0 and 100. When mark is greater than or equal to 0, 0 is okay, and mark is less than or equal to 100. At the end of the loop, I'm going to put a little statement. Thanks. And of course, after this, we might have our program that changes the mark to level or whatever we want. This will actually not write put thanks. This won't execute until this is true. And hopefully so enter a mark from 0 to 100. So let's put in -8. And then it just says, please enter a mark from 0 to 100. Let's put in 120. 1000. It's looping in here still because this is not true. Now, as soon as this is true, it'll exit the loop. So how many times the loop runs doesn't matter, but it's controlling what type of numbers the rest of your program will have. It's controlling the user input. The user doesn't have a choice to enter anything besides a mark that makes sense. So I had that example in there, and you want to get that into your notes, please, and thank you. Next, I think I only have one more little point here. Remember, no, I got a couple more points. Remember, when placed in a loop, the following statements, so remember, if I have a total equals total plus new number, that when placed in a loop will add up all the new numbers and place them in this spot called total in memory. It keeps a running total. Count equals count plus 1. Every time this command is executed, it adds 1 to count, and then essentially it can count how many times a statement is executed. And so, if we wanted to, we could change our bowling average program to have a little more meat to it. And I want to show you this. So for instance, and I've got this code in there as well. I want to show you how it works though. I have a count, I have a total, I have a new number, and I have an average. And look at the loop end loop. It says, I'm not asking for how many bowling scores ahead of time. I'm just going to, it's going to say enter your bowling score or negative 99 to quit. So negative 99, by the way, is what's called a sentinel. A sentinel. And it's a signal to the program of when it's to quit. Before it was, would you like to stop? Yes. Yes would be the sentinel. It gets the new number. Then as long as new number is not equal to negative 99, then it's going to add it to the total, add 1 to the count. If it is equal to 99, then it's going to exit. It'll calculate the average and then output the code. Now this will work no matter how many numbers I enter. So 50, 100, or 1,230 silly bowling scores, I realize. And then if I want to quit, I put in negative 99. It says you bowled an average of blah in 4 games, and it counted the 1, 2, 3, 4 games that I actually bowled, or I entered the correct. And this would work if I had 15 games or 1 game. The only case, do you see the case that would not work? What happens if I ran this and put in negative 99 right away? Do you see what would happen? What would count be equal to? Division by 0 in real expression. So what I would have to do is I would have to add code to my program that handles that case where the person has entered no bowling scores, because I don't want to have to divide by 0. I don't want my program to crash. So keep those sorts of things in mind. I have that program there. You can either copy it or use the picture tool if you're using Smart Notebook. That's fine. And then there's a bunch of exercises for you to do. And we're going to be spending a couple of days on these exercises. I want you to do a good job. These conditions can be, can get difficult. And notice that our programs are starting to have ifs within loops, and you're going to have fors within loops and loops within fors and all these sorts of things. Your programs are getting more complicated. So please think hard, try hard, ask questions when you're stuck.